Hello everyone, my name is Janvita and today I am going to discuss on the topic operations on signals from the subject signals and systems. Let's know what's a signal. Let's have a brief discussion about signal. A signal is a physical quantity or a function that carries information about a phenomena such as electrical current, sound wave, or temperature by varying over time or space. In electrical engineering, a signal is often an electrical quantity like a voltage or current and that varies with time to transmitted data. Signals can be generated by transducer, which converts one form of energy into a signal, such as microphone converting sound wave into the electrical signal. We have different types of operations on signals. Let's discuss about this one by one. First one is time shifting. Second one, time scaling. Third one, time reversal. Fourth one, amplitude scaling. Fifth one, amplitude reversal. Sixth one, addition of signals. And seventh one, multiplication of signal. Let's check one by one. Let's discuss about time shifting. As you know, what it is meant by shifting, moving from one place to the another place. Now, the same terminology applies to time shifting. Here, time shifting means shifting is a signal operation that moves a signal forward or backward in time without alternating its shape or amplitude. Here, let's have a clear-cut example to understand it. Time shifting case 1. When k greater than 0 is a case of time shifting. X of t time shifting k equals to 2. Y of t equals to x of t plus 2. Here t plus 2 equals to 0, t equals to minus 2. So the signals moves backward. Yeah, let's discuss about time shifting with an example. Continuous. If x of t equals to sine of t, then we have a question y of t equals to x of t minus 2. Here it says that it's shifted 2 units right side. So sine of t minus 2. Discrete. X of n equals to 1, 2, 3, 4. Then y of n equals to x of n minus 1. We'll get 1, 1 plus 1, 2, 2, 3 plus 1, 3. And it's shifted by one sample. Let's discuss about time scaling. Scaling time in the context of signal processing and artificial intelligence refers to manipulation of a signal time axis by multiplying the time variable by a constant factor alpha resulting in compression. If we multiply it, the signal compresses. If we divide it, the signal expands as you check in the example. Here it Now let's discuss about time scaling using an example. Continuous signal. X of t equals to cos of t. Then y of t equals to cos of 2t. Here t equals to 2t. It's multiplied by 2. The signal becomes fast and compressed. As you know that if we multiply any signal, it will get compressed. If we divide any signal, it will get expand. For discrete signal, x of n equals to 1, 2, 3, 4. Then y of n of x of 2n equals to 1, 3. The sample at even in indices only. Now let's discuss about time reversal, the third operation of a signal. What do you mean by reversal? Reversal means shifting of the time or reversing the time. Time reversal is an operation of reversing the order of a time in a physical equation or a signal. As you see that a signal is in first quadrant, it is shifted into the second quadrant. If the signal is in second quadrant, it is shifted into the first quadrant, vice versa. Now let's discuss the fourth property, amplitude scaling. Amplitude scaling is a process of altering a signal strength or a magnitude by multiplying its original amplitude by a constant scaling factor. Here in this amplitude scaling, we will multiply a constant before the function. If y of t equals to x of 2t, we will multiply a constant before x of 2t. Yeah, let's discuss about this property using an example briefly. Amplitude scaling. Continuous x of t equals to e power of minus t. Then y of t equals to 3 into x of 3. Here 3 is the amplitude scaling factor, which is represented as amplitude 3. Now 3 into x of t equals to 3 into e power of minus 3. Amplitude is multiplied by 3. For discrete, x of n equals to 1 minus 2, 3. Y of n equals to 0.5 into x of n. Now 0.5 is divided to each number. Now, as we know, 1 divided by 0.5, it's 0.5, minus 2 divided by 0.5, it's minus 1, 3 divided by 0.5, it's 1.5. Now let's discuss about another topic, amplitude reversal. What is an amplitude reversal? Amplitude reversal is a signal processing operation that creates a mirror image of a signal about its horizontal axis by multiplying the signal amplitude. As we know, as we learned that time reversal, here it shifts the coordinate from first quadrant to second quadrant and second quadrant to first quadrant. But here it shifts from first quadrant to fourth quadrant and second to third, as is shown in the figure. Now let's discuss about another property, adding a signal. What do you mean by adding a two numbers or a two digits? Now we'll add a signal here. Adding a signal involves summing the amplitude of two or more signals at each corresponding point in time to create a new signal with a combined characteristics. Now, consider x of t is one signal and y of t is another signal. Now, summation, there's some z of t equals to x of t plus y of t. Let's see in the picture more clearly. Here it is given that x of t, a rectangular signal representing minus 3 to 3 with an amplitude 1. For x of 2, here representing minus 10 to 10 with an amplitude 2. As z of 3 is addition of 2. It represents minus 10 to 10 at an amplitude 2 first and at an amplitude 1, which gives total amplitude is 3. Let's discuss about this more briefly using an example. Addition of a signal continuous. X1 of t equals to sin t, x2 of t equals to cos t, y of t equals to x1 of t plus x2 of t. As we know, sin t plus cos t. Discrete, x1 of n equals to 1, 2, 3, x2 of 2 n equals to 4, 5, 6. Now adding 4 plus 1 will get 5, 2 plus 5 will get 7, 3 plus 6 will get 9. Now let's check the last operation on signals, that is multiplication of signal. As we know, multiplication of a signal is multiplying a single digit number, two digit number. Now we'll multiply a signal in this. Signal multiplication involves creating a new signal by multiplying the amplitude of two or more signals at each corresponding point in the time. Here we need to observe one thing. Here we'll get the output signal as the common part of x on x2. Now let's check it in the figure. As you know, x1 of t is minus 1 to 3 with an amplitude 3 and 0, x2 of t is 0 to 2 with an amplitude 2. As we know, the common part is from 0 to 2 at an amplitude 6. Here the amplitude will be multiplied with each other, but the time period t will not multiplied with each other. So we will take the common part for the t and amplitude will be multiplied to each other. As we know, 3 into 2 equals to 6. Now as we know, the common part is 0 to 2 as we combine between x1 of t and x2 of t. Yeah, here is the y of t generated, 0 to 2 and amplitude is 6. Yeah, let's have a brief discussion about this using an example. Multiplication modulus. Continuous, x1 of t equals to sin t, x2 of t equals to cos t. Now y of t equals to x1 of t into x2 of t, sin t into cos t. For discrete, x1 of n equals to 1, 2, 3, x2 of n equals to 2, 2, 2. 1 into 2 will get 2, 2 into 2 will get 4, 3 into 2 will get 6, y of n equals to 2, 4, 6. Thank you.